Welcome to Weather Unlocked number 46, Aviation Part 2. In Part 1, we dove into the science behind aviation forecasting. In this video, we'll focus on the services the National Weather Service provides to the aviation community and how that impacts their operations. Let's get started. There are three main branches of the National Weather Service that support the aviation industry. The Aviation Weather Center, located in Kansas City, Missouri, 21 Center Weather Service units scattered across the country, and 122 weather forecast offices, which are probably what you think of when you hear National Weather Service. Each branch provides different types of weather information to the aviation community to provide a more tailored, valuable forecast. Let's start with what weather forecast offices do. Weather forecast offices provide gridded hourly forecasts of wind speed, wind direction, cloud cover, cloud base and ceiling height, lightning, precipitation type, precipitation amount, visibility, and low-level wind shear. All of these variables impact aviation operations in some way, and our partners want to know how they're going to change over time. So, who uses this information? Weather forecast offices primarily support the aviation community by developing terminal aerodrome forecasts, or TAFs, for airports across the country. These TAFs are used for planning purposes and to keep pilots informed of current and future weather. TAFs are generated 4 times daily but can be amended if the forecast becomes unrepresentative of observed or expected conditions. Why does the forecast matter? Well, according to FAA statistics, weather is the cause of approximately 70% of all delays in the national airspace system. In fact, in 2022, weather impacts cost the aviation industry approximately $30 billion. Needless to say, stakeholders have great interest in trying to mitigate these losses as much as possible. So next time you're traveling by air and experience a delay, there's a good chance it was caused by weather, and there are meteorologists at the National Weather Service working 24/7 to keep you safe. We mentioned that TAFs are the primary way weather forecast offices support the aviation community. But what does a TAF look like? The top line here represents the current conditions: wind speed, wind direction, visibility, and cloud cover. The subsequent lines represent changes in the forecast conditions over the next 24 hours, written in UTC time. Here we put the expected wind information. The first 3 digits represent the north relative wind direction, while the next 2 digits indicate the wind speed in knots. So in this bottom line, the wind is forecast to be blowing from 350 degrees, or northerly, at 8 knots. Next is the visibility measured in statute miles. And the final group contains the cloud cover and cloud height information. In this case, SCT stands for scattered clouds, and the next 3 digits represent the height in hundreds of feet. There may be additional groups added to each line if the weather is more active, but for simplicity purposes, we'll leave it there for now. This information is vital because pilots are rated to fly only in certain weather conditions, grouped together in flight categories shown here. Essentially, pilots have to go through additional training to fly in airspace with low visibility and low clouds, as they have to rely on onboard instrumentation. That's why meteorologists make sure their TAFs are as accurate and up to date as possible. However, in order to keep the TAF easily readable and accessible, they are written only to denote significant changes in the forecast over the next 24 hours. They are not meant to provide an hour-by-hour forecast. Now, let's take a look at the roles of the 21 Center Weather Service units, or CWSUs, across the country. The CWSUs concentrate fully on producing specialized forecasts and advisories of thunderstorms, turbulence, icing, and precipitation affecting the national airspace system. These face-to-face and on-the-spot briefings convey a variety of weather information to air traffic controllers and are vital in helping FAA personnel safely and efficiently route air traffic. The catalyst that placed meteorologists in each air route traffic control center was the 1977 crash of Southern Airways Flight Number 242, which flew into a thunderstorm and crashed en route to Atlanta when both engines flamed out due to hail ingestion. The ensuing investigation suggested that air traffic controllers needed a better way to receive timely weather information. Hence, the CWSU program was born. Finally, there's the Aviation Weather Center. They're responsible for disseminating information on a larger scale than WFOs or CWSUs. They develop warnings called SIGMETs of hazardous weather for aircraft in flight and forecasts of weather conditions for the next 2 to 4 days that will impact both domestic and international aviation. The Aviation Weather Center leads the collaborative effort to develop a forecast of expected convective events for the entire country every 2 hours, used by the FAA to manage air traffic flows across the country. So, how do these three branches work together throughout a flight? Essentially, WFOs provide the forecast for takeoff and landing, CWSUs cover the initial ascent and approach, and the Aviation Weather Center manages the flight en route as it's cruising. Each role is vital in keeping pilots informed and keeping passengers safe, which is the number one priority of the National Weather Service. That's all for this video. Be sure to subscribe to our YouTube channel for upcoming videos in the Weather Unlocked series, and feel free to check out our previous videos on a wide variety of weather topics.